If you are here for stack smashing, then you're in the right place. If not, I'd still like you to enjoy the talk and see me after, and I can validate your parking. If you go to the link speakerdeck.com/u/Czarneckid, I've posted the slides online so that folks in the back, if you cannot see the 2 projection screens, I know in some of the other rooms it's been a little wonky to be able to see the slides easily, so you can follow along at home. Hopefully you'll stay for the entire presentation. My name is David Czarnecki. Like most of you, I am on Twitter at Czarneckid, so if things like Ruby, Rails, video games, pictures of food, snowboarding, beekeeping are your thing, then follow along. It'd be great. Like most of you, I also have code up on GitHub at Czarneckid. I work for a company called Agora Games. We do middleware for video games like Guitar Hero, Call of Duty, Brink, Blur, Mortal Kombat, Saints Row the Third. If you've played a major video game, we have data that may be going through our system. And we're also a part of Major League Gaming, so we handle all of their online properties, and that is what I'm going to be talking about today. Basically simplifying your infrastructure and a lot of the lessons learned, or what I think are big lessons in managing 16+ applications on minimal hardware. We also have a number of libraries that we've open sourced that you may find useful out on GitHub. So infrastructure insanity. When I was putting together the description for the talk, I mentioned that basically the impetus for this came about from taking what was close to 100 virtual machines and collapsing them down onto 2 physical boxes, hence stack smashing. Obviously, we have a number of other utility boxes for like database and Memcache and Redis, but for the most part, our applications run on 2 physical servers. And so this was, there we go. This was priority that was on the whiteboard for our CEO, and he had a number of projects, and I was coming off building some other applications, and he had asked, hey, we've got these initiatives that nobody's really working on. What would you like to take on? And so operations or server management, server infrastructure, not necessarily something that I had been involved with or had done before. So as a full stack developer, or what I like to consider myself as a full stack developer, just like to get more experience in this area. So it's a project that I took on. Originally, it was supposed to be kind of a 1-month tour of duty, but I think as I found in a company, if there's anybody who likes to worry about infrastructure and servers, that most people say, oh, that guy's got to worry about it, that's great. I do not want to have to worry about it. And so it's kind of extended since last September until now. So the goal was really to simplify all of the things, and by all of the things, I mean we had VMs for all of these different applications, and I'll go into kind of the infrastructure a little bit more, but simplifying that down so that you can make sense of all the applications, how they're kind of intermingled, and how they talk to each other, and how that's all managed. And also a side effect to, there we go, to document all the things. So going through the process, making sure that the whole engineering team knew what was happening and was in the loop as far as the decisions that were being made, as far as the technologies that were being picked. So just a brief overview of the network that we're talking about here for Major League Gaming. Come on, there we go. So 15 applications intertwined. This is just, I've highlighted the bigger applications that we have. So we've got Pro Gamer, which is player profiles, pulling stats, MLGTV, video on demand, user-generated content. We've got a StarCraft Arena site for doing StarCraft tournaments. Our live experience when we have these pro circuit events 4 or 5 times a year where people can go and mix and match different video streams. Obviously, we sell membership and other paraphernalia on the web. SSO, our single sign-on that basically all the network applications talk to know about who you are across the network. So a lot of applications, and as far as computing needs, excuse me, just some pretty simple math here. We've got the number of apps times, say, capacity that we're looking at for the apps. Then at a minimum, we probably want 30 virtual machines. So if one goes down, we can fail over to another. But obviously, there are going to be applications that are going to be hit harder, and at certain times of the year, or maybe for certain weekends, you're going to want more capacity in certain areas, so you're going to have even more virtual machines. Pretty stock one that we're using, we're hosted in rack space. A gig of RAM, 40 gigabytes of disk will probably allow you to run a few thins and some extra memory to grow there. Traffic numbers, not the biggest, but also not the smallest. So we're in the millions of views and page views a month. So certainly not insignificant traffic that we're dealing with here. So we quickly needed a lot of VMs to make everything scale, which is great, but it also means it's a lot of money, variable cost. So we can get physical servers to have fixed costs, known computing resources, and obviously the more servers that you have, your infrastructure's that much more complex, harder to understand, harder to manage. So we love hardware a lot. This is a profile of the boxes that we have set up for our app servers, 4 processors, 6 cores per processor, a lot of memory, a lot of disk. There's also hyper-threading that's enabled on these machines, which is awesome. So it kind of looks like more cores or something along those lines, but really, really fast machines. We do all of our server provisioning and management in Chef. I don't care what you use for managing your servers, but do something that is not manually installing software on those servers. So our Chef recipes mostly stock, and I'll talk about where those diverge and have some code samples up there. I want to talk a little bit about application migration. So we had all of these 16 applications that were running on VMs that we were migrating to the physical servers. Obviously, start internal with your applications. So start with the tool that an internal department uses that may not be your main site right away, so that you can understand the issues that you might run into in deployment or not having things set up on the server right away, and end with all your external facing applications. By the time we got to the last ones that we were switching over from the VMs to the physical servers, we had encountered all of the problems. We encountered all the use cases, as far as machines needing rescue or non-Rails applications that we needed to support. So what I found is the iteration, doing that again and again, that's where you get the abstraction. That's where you can find the patterns that you can apply to your infrastructure. Along the way, we're pretty self-directed as far as the technology that we're using. All of our applications were Ruby 193, Rails 3. So in doing the upgrade or in doing the move from VMs to physical servers, we're also doing upgrades from Rails 3 to Rails 3.1, which mostly means the asset pipeline. So I'll just talk a little bit about kind of how we went about doing that. Obviously, you can check out a branch, your Rails 3.2 branch, set your Rails gem to 3.2.0 or whatever it is now. The asset pipeline is optional. If you do nothing else, you can turn off the asset pipeline, use the new version of Rails, and be done. But if you do decide to do the asset pipeline, oh my God, spelling mistake, that's awful. It really amounts to grouping these few gems in your gem file, adding some bits to application RB for doing the assets, making sure that the asset pipeline is enabled. Excuse me. Telling Rails what assets to put in the pipeline and precompile for you. Again, all these slides are available online, so don't worry about taking copious notes. And then moving your assets from the public directory over to the app assets directory. For the most part, that was the upgrade process for us. Your mileage may vary. We were also moving at the time too from thin to unicorn, and so I'll talk a little bit about what we found were some really nice things about unicorn. It's really fast compared to some of the other servers. They have benchmarks on the unicorn website. It manages worker processes for you, and it does so at the kernel level. The operating systems nowadays are really smart at doing that for you. Algorithms that you're probably going to do for load balancing across a number of workers, maybe not as smart, so let the kernel manage that for you. It can do rolling restarts where you can send a signal to your unicorn process and have your application kind of do rolling restarts where it restarts the workers individually so that you can do zero downtime. There's actually another talk going on right now about zero downtime deploys. Imagine probably something similar is going to be mentioned there. You can also send signals to the unicorn process to get capacity. This was really nice for us. What we found is developing a couple of Capistrano tasks to say, I'd like a couple of more workers handling the store, or I'd like a couple more workers handling MLGTV because it's getting a lot of traffic this weekend. So we can send a signal and basically have more workers handling the load for an application as opposed to spinning up more VMs and provisioning software or provisioning another server to handle that for us. This is our Rails run recipe for Unicorn. Our applications, we have some that do use Unicorn Rails, which basically sets the Rails environment, versus Unicorn, which just sets your rack environment. And so we have support for specifying which Unicorn command you'd like to run. We tell it where the configuration for a Unicorn is, and I'll show that in the next slide. So we set up the environment for the worker processes that we're going to have for our environment. We can change depending on whether we're running in production or development. So I think the minimum that we use is 4 worker processes for an application. Timeout of 30 seconds. If you have an app which is handling requests which go over 30 seconds, they should be killed. I mean, that's an error in your application. Unicorn also will backlog requests for you, and so you can set a backlog of for the different worker processes to up to that limit, and then it'll handle the ones as it gets to them. Service configuration. So this was an interesting one that bit us one morning. So if a server fails, here we go, does it make a sound? Interesting question. No, you get a phone call at 7 a.m. that says, production is broken, so you need to fix it. So we'll take a look at what I think is one of the usual suspects here. So here's typical database YAML for production. Looks pretty stock, right? Can you spot a problem in the database YAML here? Host machine name. So imagine you have that spread across 16 applications and your primary database server crashes. But databases never fail, right? They do. So what we did is, for those services, we put in an alias. We run internal DNS for our applications. So instead of the applications kind of referring to machines directly where MySQL might be running, we set an alias in DNS which says MySQL.ourcompany is cnamed to a particular machine. So what happens is we change that in database.yaml, and no redeploys if MySQL fails and we have to switch over to another server. So no redeploys. We don't have to update any YAML file. All we have to do is update DNS. The applications restart. Everything is happy. Obviously, do this for Redis. Do this for Memcache, any other services. Just a nice way of kind of shielding you from having to make updates to 16 database.yaml files, doing 16 deploys. You probably do offline processing. We do that as well. We use Rescue and love it. Have not had problems with Rescue. So we've made our Rails recipe Rescue aware, and I'll show that a little bit. So in our configuration in Chef, where we configure all of our applications, we say what queues our application is going to use, and you can set different intervals if you want certain queues to process things faster. The default, I think, is 5 seconds for Rescue, but excuse me, we allow you to override that in the configuration here. And we have, I know this is a little bit hard to read, but each of our worker processes is managed as a separate service in the operating system, so that they're independent of one another. If they fail, they get restarted automatically. And this is just a little bit of what our rescue run script looks like. We tell it which environment, what queues it's supposed to operate on, the interval for that queue, and then it basically does work. We use Capistrano to do all our deployments. Question?
Are you using RVM?
Yeah, we are using RVM.
What's the benefit of using Conf?
I guess it does. I don't know offhand, but it's. I assume it was just pulling in all the gems for the application, since we have gem sets for all the apps, so keeps them isolated that way. Yeah, so we use Capistrano for our apps, and I'll talk a little bit about what I think is sexy Capistrano. And by sexy, I mean dry, so not repeating yourself. Again, when you have 16 applications, you don't want to repeat the same thing in all of the applications. So here's a bit of deploy.rb. So for all of the applications, this is what deploy.rb looks like. If your deploy.rb is more complex than this, I would say you're not necessarily doing it wrong, but there's opportunity for you to do it better. And basically, the deploy.rb really just sets up all the things that we want to use in our application, like air brake, things for the asset pipeline, HipChat notifications on deploys, unicorn tasks, rescue tasks, what queues our app is worried about. I'll go into a little bit about where we've gemified that into our Capistrano Agora gem. It's not anything that's public, but I would say just something that you can do as an organization to pool those things together. Basically common functionality. This is what our gem file looks like. So we use Capistrano. We pull in Capistrano Agora. Makes sense for more than one app. If you're repeating yourself more than once, obviously there's room to compartmentalize that. Just the different focus areas that we have. Again, air brake, HipChat, rescue, unicorn. This is what base.rb looks like. Pretty stock, where we're just setting things up for SSH forwarding through a gateway, which repository we're going to look at for an application, so that you don't have to have that in your deploy.rb. You have to have minimal information to get set up and started. Asset.rb, this was an interesting one. So with the asset pipeline, we have a few applications which use that heavily, but assets don't necessarily change from deploy to deploy. So this is a little bit of code that I had written to detect common areas where assets may have changed, and then it'll look in Git to see if it has changed, and if it does, it recompiles your assets for you. If it doesn't, it just takes the assets from the previous deploy, copies them over, really quick deployment. One for rescue. So again, all of our workers are managed independently. So what this does is for each one of the queues goes and restarts the worker on deploy. When I talked about Unicorn before, I mentioned signaling for capacity. So these are the Capistrano tasks that we have to basically look up the Unicorn process ID for a given application and say, I'd like X number of workers more for this application. Or after a weekend where we don't need that many workers running, we can just decrease the number of workers. So application monitoring, just a few thoughts on that. It has to be visual. It has to be something that somebody can look at graphs on a web page and look at historical information over time and say, yeah, this is kind of nominal requests per second, or NGINX status, or number of keys that you have in Redis, whatever it is, so that you can see, as opposed to kind of making a value judgment of, well, the app seems slow, maybe we're getting more requests to a given application, but when you can actually see it on a web page internal, then it makes a world of difference. So again, it must be historical, something that you can look at over a given period of time to again, make judgments as to, this is from week to week, this is what we expect to see with different services in our infrastructure. Has to be accessible. Developers, managers, anybody in the company has to be able to look at that and kind of ask questions about it and wonder why things are the way they are. So we use Munin, and really nice tool. All of our servers basically check into a central Munin server. The chef recipes know how to categorize different machines based on what services are running on a machine. Can spot problems and spot opportunity for your apps. This is just a few graphs. The top one, we actually keep a log or a tally of the last time since an application has been deployed. So all the lines on top are, we haven't deployed those apps in a while. And we do continuous deployment, or continuous integration and continuous deployment. So you may wonder why apps haven't been deployed. Maybe somebody's not working on them, or something else is wrong. Bottom left is NGINX responses. The peak on the one all the way to the right, we had to investigate, why were we getting all of those 500 errors on the 22nd? And then the bottom right is Redis, so operations per second. And again, you can see that I took the graphs by week just to give you some visual history of, kind of how things look nominally. And if all of a sudden, we were doing 10,000 operations per second in Redis, we would want to understand why that is. Is it some errant process? Do we have something that is using Redis more heavily, or what's going on there? We do infrastructure monitoring. So this is kind of an interesting system engineering project. The folks who we had doing more the dedicated system engineering had taken on. So we actually do BDD on our infrastructure, something I would actually highly recommend, whether or not you use Cucumber or not. But we do BDD or TDD on our apps, so there's no reason why we can't do the same thing on our infrastructure to know that things are set up the way that we expect them to be set up. So we have this Rackspace validations project, which runs every 5 minutes. Cover the step definitions in a little detail. So we've got command steps. Those handle running commands on different servers. DNS steps for doing DNS lookups, making sure that machines are aliased the right way. File steps may be where we want to check a directory to make sure backups are being run, that they're not older than a certain date. And ping steps, are machines alive and actually running on the network? To show these in a little bit of detail. So if I go to a particular HTTP or a particular web address, do some retries, handle connection errors and timeouts for us. Steps to, if I go to a given URL, take a look at the output that exists on a given page. It should contain this, it should not contain that. The third one down, the output should contain something where X is less than something or other. We use that for doing checks on our MySQL slaves so that they're, we're checking to see that the slave isn't behind some large amount. DNS steps, when I do a DNS lookup for a given name, it should point to the right place. File steps, making sure that there's a certain number of files in a directory or not, that the most recent file should be modified and not less than some given time interval for us. Pings, when I ping a host, it should respond. I should get a response within some tolerance. Here we go. Go into a little detail on the features that we have. So we've got applications, Memcache, Mongo, MySQL, NGINX, Redis, Varnish. We'll cover a few of those, just some of the Cucumber steps that we've got there. So applications. So ensure the company site is available. So when I go to the company site, I should get a 200. The site should be available, or at certain times we may expect that we're going to get a redirect to a certain place in the network. We do that on our live events where certain weekends will automatically redirect people to the live experience, for example. MongoDB, I like this one. This one's pretty funny. Shows the systems guys have a sense of humor. So in order to support the environment as a responsible system administrator, ensure the MongoDBs are running, that we have good slaves in the masters, but actually secondaries to primaries since it's MongoDB, and that our snapshot backups are up to date. So basically goes to each of those machines, greps for the Mongo process, make sure that it's running. Really simple sanity checks, but again, you're just validating that your infrastructure is how you think it is all the time. Redis, going to a machine and making sure that Redis is up and running and is the right version. You may have certain version requirements for why you would use a certain version of Redis versus another. The last two sections are on continuous integration and continuous deployment. We use Jenkins. Hopefully you have some continuous integration set up so that not only are your developers doing TDD and validating the code that they check in works, but you have some sort of, not necessarily a gatekeeper, but some other process which is validating the code as well. Jenkins is great, integrates with a lot of different systems, has support for so many different things. So Jenkins for us builds all our internal projects, all our internal gems. We use Gem-in-a-Box Secure, so we have an internal gem server for all of the gems that we write that we're not going to publish, but just so that we can have a gem server and do gem stuff, do releases in the same way that we would do our open projects. So our gem files look like we give a source of Ruby gems, but then we also have a source of our internal gem server. When we do Gits, where we actually need to pull in a Git project, if I imagine you probably have applications where you're doing this, fork that project into your organization for one reason: shields you from info suicide. Your organization is probably not going away, but as we've seen with a number of people in the Ruby community, the Python community, all of a sudden their code can go away. Your code depends on their code. Your code magically breaks when you go to deploy. So really simple way of kind of shielding you from that. On build failure, who are you going to notify? Not the Ghostbusters, but send out an email. We do email notifications where the entire engineering team knows that something's broken. We do HipChat notifications. Basically, I'm of the opinion that the more in your face that you can be that something has broken, the better. I always like to see that the next commit after something is broken to be commits trying to fix it. It's understandable, but I've seen organizations where something breaks and people are committing code, and it's a snowball or a hairball, I guess is the meme of the conference this week. We do, excuse me, continuous deployment as well. It's sort of opt-in, I guess. We only have it on a few projects, but something that can be easily set up. So the idea being that smaller changes go out more often so that you don't have these huge feature releases going out where you need to worry about having a team on hand or a bunch of people to support something like that. We've adopted GitHub Flow. If you don't know of it, pretty quick rundown. Everything in master is deployable, and all of our features are developed in branches. and we do pull requests and as a way of doing code reviews to pull all that back into master. Once master builds in continuous integration, it gets deployed. So we have a post-build script trigger, which looks like this. If we're on the master branch, then basically notify the project-deploy project to build, and otherwise don't do anything. So make sure to click the checkbox to only execute that if the build succeeds. You don't want to the project-deploy for whatever project it is sort of dumb that it'll do the deploy regardless. So just as a check there. We set up a project-deploy for whatever project we have, which is pretty straightforward. Just runs, in this example, we have it's a project that uses SQL, so we just do a deploy with migrations for our deploy user for the given branch, and it deploys. And nobody has to do that, but all of the normal stuff happens as far as HIPchat notification or email notification that the deploy is going out. So just to quickly recap, since I think we have about 5 minutes or so, maybe 10 minutes. Simplify your infrastructure as much as possible. I have an interesting game that I like to play. Take all of the servers that your company manages and just kind of rapid fire have somebody ask you for a given server, you have to tell them what its role is. And you get bonus points if you can do that by IP address. But if you have so many machines where somebody asks you, well, what does link run, or what does Mega Man run? If you can't answer that, your infrastructure is not necessarily out of control, but you really need to understand what are all the moving pieces beyond just the software. You need to understand where your software is running as well. When you're doing upgrades, as we found, small to big, you will learn all of the patterns from doing things over and over again that you'll be able to abstract into either reusable components or figure out what changes you need to make to your recipes to support different bits of functionality. Aliasing for services goes a long way. We have 16 plus applications now. If we have to fail over any of the services, I can do that within a second. So downtime is minimal, doesn't require any deploys for making sure that the applications operate continuously. Don't repeat yourself. We did that with Capistrano, where we took all of the functionality that we had across the 16 applications as far as deployment and packaged that up in our own gem so that the deploy script or the deploy.rb for our applications is relatively homogeneous, that it all looks the same, and really all your kind of wiring in there is what bits of functionality do you need? Do you want HIPchat? Do you not want HIPchat? Does your application need to do air brake or not? Monitor your applications, so make sure that you have some visual way of just validating that things are correct, that it's historical, that everybody can look at it and ask questions and kind of reason about it and make decisions as to why an application might be erroring, or why you're getting so many more requests for an application. apply the same principles to your infrastructure that you would apply to your applications to validate that things are running correctly. So you can do BDD or TDD on your infrastructure. I think there's a book from O'Reilly about that. It's called Behavior-Driven Development for Operations or Infrastructure. I forget the exact title. But there's no reason that you shouldn't be doing it. I suspect most people aren't doing it, but I don't know, just a great way of validating that things are working as expected. Obviously, integrate all the things. So all of your software. Don't just do that on your developers' machines. Have some other system, like continuous integration server, that will do that validation check for you. We've had projects where we've done the continuous integration, and we found issues where it's really just kind of load order things, where specs are loaded in a different way on a developer's machine versus the continuous integration server. And it's found a few bugs. So it's just interesting that you'll say, oh, it works on my machine, but you run into a weird case where things happen out of a certain order of expectation, and you need to kind of take that into account. So again, the slides are available on SpeakerDeck. You can go to that link. This is the cornflower blue theme, but you can also get it in ruby red for your viewing pleasure. Twitter, GitHub, and thank you for coming.